Hey, good morning, good afternoon, good evening, guys. Hopefully you're doing well. Okay, guys. We're going to be talking about ratios, specifically mole ratios today. I kind of touched on this last week. We're going to get in more detail today. I'm having some computer issues, so you're not going to be seeing my face, but that's all right. We'll get through this together. So first up, let's talk about what is a ratio. Right? What does that word mean? And we can see that a ratio is a relationship between two amounts. Okay, so there's 4 quarters in a dollar, so that's a 4-to-1 relationship between quarters and dollars. Okay. A lot of times these amounts involve how many of one amount is in another. So if we see this bowl of fruit here on the right hand side, we can count that fruit and we can see that there are 9 pieces of fruit in that bowl in total. Okay. But what if I want to know how many apples are in that bowl compared to the total number of fruit? Well, a ratio could tell me that there's 5 apples to 9 pieces of fruit. Okay, so 5 for every 9. Okay, so for every 9 pieces of fruit, let's say this is the ratio that we live with. For every 9 pieces of fruit, you would have 5 apples in it. Okay, or plums. Well, if I count the plums, there's 4. So there's 4 plums for every piece of fruit in the bowl. And then now I can also compare the different fruits together. So apples to plums, right? I have 5 apples for every 4 plums. So you can see these ratios. Again, 4 quarters in a dollar is a ratio. Right now, statistically speaking, women make 0.7, all right, or 70 cents for every dollar that a man makes. That's a ratio, 0.7 to 1. Okay. But what if, kind of tying this back to stoichiometry, right? What if when you bought fruit, you had to buy it in the ratio of 5 apples to 4 plums? Okay, 5 apples to 4 plums. How many plums, all right, or what would that mean if I wanted 15 apples? So my ratio is 5 apples. I'm just going to put A. I'll just do all of it. All right, to 4 plums. Okay, so ratio of 5 to 4. So if I wanted 15 apples, that would be times 3, right? I'd get 15 apples. Well, since for every 5 apples I buy, I get 4 plums also, that would mean I'd also get 3 times as much as that. And so I would get 12 plums. Okay. And that still maintains my 5 to 4 ratio because I multiplied 5 by 3, multiply 4 by 3, 15 to 12. Okay. So it's just kind of something to think about as far as ratios go, that this is set, right? This is set. 5 to 4 is set. And so no matter how many apples I buy, right, or how many plums I buy, right, I get the other amount. Hopefully you're kind of catching my drift. If I buy 5 apples, I get 4 plums. If I buy 15 apples, well, I get 12 plums because I got to maintain that 5 to 4 ratio. So another way to kind of look at it, right? If you're a baker, you learn that the ratio of bread to water in your bread recipe, sorry, not bread to water, flour to water in your bread recipes is about a ratio of 5 to 3. Whatever it is. If it's tablespoons, it's 5 tablespoons flour to 3 tablespoons water. If it's cups, it's 5 cups of flour to 3 cups of water, right? Or thereabout. Okay, and so if I end up using, say, 6 cups of flour, let's go back to our whiteboard here. And if I end up using, so it's 5 to 3, all right, flour to water, of L-O-U-R, This is really hard, just so you know. FLOUR to water. Okay, so if I used, say, 6 cups water, right? For this ratio, I would need, let's see, 3 times 2 is 6, so 5 times 2 is 10 cups of flour. Okay, so because I have to maintain that 5:3 ratio. All right. So let's kind of look at this even another way. All right, so we're going to go to the simulation here. All right, and this kind of helps us visualize what's going on. So here's my ratio. For this cheese sandwich, I have 2 pieces of bread and 1 slice of cheese. That's my ratio, 2 to 1. For every 2 pieces of bread and 1 piece of cheese, I make 1 sandwich. So 2 pieces of bread, right? I don't have any cheese, I can't make any sandwiches. 1 piece of cheese, 1 sandwich. What if I have 4 pieces of bread and 1 piece of cheese? I can make 1 sandwich and have bread left over. So you can kind of see I have to maintain that ratio. If I want a sandwich, I need 2 to 1 over here. So that would be 2 to 1, 4 to 2, 2 to 1. All right, hopefully you're seeing this. If I go 5 pieces of bread and 3 pieces of cheese, look, I still only have 2 sandwiches because I got to maintain that 2 to 1 ratio. 2 to 1. Okay, so let's look at meat and cheese. All right, this has 3 things: 2 pieces of bread, 1 piece of meat, 1 piece of cheese. So if I have 2 pieces of bread, I don't make anything. If I have 2 pieces of bread and 1 piece of cheese, I don't make anything. All right, so you can see, like, when I hit the right ratio, 2, 1, 1, I get that meat and cheese sandwich. Okay, so hopefully you can see, if I do 3, 1, 1, right, I'm not making another sandwich. I can have 2 pieces of bread over here, but I'm still not making another sandwich because I need that 2 to 1 to 1 ratio. Okay. So the coefficients in a chemical equation are the same way, right? They have a relationship. So here, actually, let's go back real quick. Go back to our simulation here. I'm going to switch molecules. So you can see here, hydrogen to water, I need 2 H2s for every 1 oxygen. So there's an H2, there's an oxygen, but I'm not making any water, right? And that's because I don't have the right ratio. If I add 1 more to it, boom, I have 2 H2s for every 1 O2, and I make 2 waters. If I get more oxygen, I'm not making any more water unless I get those 2 things. So the coefficients up here are the same way. I need 2 pieces of bread and 1 piece of cheese to make a sandwich. Here I need 2 H2 molecules and 1 O2 molecule to make water. And if we come here, okay, so this is sodium hydroxide and sulfuric acid reacting together to make water and sodium sulfate. Okay, this is a balanced equation. So the relationship between sodium hydroxide and sulfuric acid is for every 2 sodium hydroxides, okay, I need 1 mole of sulfuric acid to react with it, right, as a 2 to 1 relationship, right, or 2 to 1 ratio. Okay. What does that mean for us? Okay. I can also look at a ratio between reactants and products. And so here, if I look at sodium hydroxide and water, I have a 2 to 2 relationship. For every 2 sodium hydroxides reacted, I get 2 waters out of it. And you can simplify that ratio as a 1-to-1 relationship. If you can simplify ratio, you should. So like previously, let's just simplify it, okay? All right, so that's, what ratios are, okay? We use the coefficients in front of our compounds to get a ratio relationship. Sorry. And I hope that was helpful.